Ladies and gents, the other day, so Monday, I know it seems like forever ago, but Monday, we introduced circuits and we said we're going to be building circuits, and that's what we're doing for today. But in order to do that, you also have to be able to diagram and show some of our different symbols. So do you remember what this symbol was?
Yes.
What is it?
Battery.
It's a battery. This is my positive terminal. There's my negative terminal. Now, the question is, when I put this into a circuit, so I'm going to attach it with what? What are those? Wires. What's this?
It's a light.
Light bulb. All right, now, the real question, remember, what direction does our electricity actually flow? Yeah. All right, so on our negative terminal, remember we build up all these electrons right here, and there's a potential difference between my negative terminal and my positive terminal. So when you have that potential difference, remember we have high electric potential over here, low potential over here. So remember, we always flow from high to low. So in terms of a physicist, we would always go negative to positive, right? And so we would say that is my current, that's my I. Any of you guys in engineering? No? Okay. Engineering actually looks at this a different way. They don't like to go negative positive. Like, does anybody really like to? It seems counterintuitive, right?
Exactly.
And it's just the wrong way, right? You know? So they actually will diagram the current moving like that, where it actually goes from the positive to the negative. So just be aware, you might see pictures with it going from the positive to the negative or the negative to the positive. We know, though, what is flowing? Electrons. So would the electrons flow from the positive terminal to the negative terminal?
Of course not.
No. So I'm really going to look this up, and I'm going to try to find out the real answer as to why. I've asked a couple teachers. Nobody can give me an answer as to why they do it that way. But just be aware that you might see it those two ways. Okay? And then if you end up going the physics route, it'll always be negative, positive. If you go to the engineering route, it's going to be positive to negative. So either way. All right, we also had this symbol. What was this?
That was a resistor.
That's a resistor. Do you remember what this is?
What?
That, where I have two plates. It's like charging up my disposable camera. A capacitor. Are any of you guys in the computer science classroom? None of you guys? He has little circuits up, and he can program them to do light shows. And so he has capacitors on there. So he can actually use that. Man, none of you guys are in there. Sad day. All right, so that's what we're going to be doing today. So that is what we call a schematic diagram, All right, so today's goal is to build a variety of circuits that are all in series. So if I'm looking at a circuit that's in series, and I want to put two batteries in there. How many batteries is that right now? One. Can I go like this?
Potentially not.
No, that's a negative to a negative. Is it going to flow that way?
No.
No, I have to hook a positive to a negative, positive to a negative. Now how many batteries do I have hooked up?
3.
3. Adding more batteries increases my voltage. And then look. Oops, that was a horrible light bulb. How many light bulbs do I have? 3. Which one would be brighter? 1 light bulb, 2 light bulbs, or 3 light bulbs? The 1. Why? When I add more light bulbs, that increases my resistance. So when I increase my resistance, what's going to happen to the current? It's going to go down a little bit, right? The more light bulbs that I add, the more the voltage gets divided among those, right? So when I look at this one, and my current as it goes around and back to my battery, do you see how I have one path? So if you're following along on the guided notes, that's one of the things that says paths. There's only one path. My current, because I'm on the same path, I'm on the same road, is going to be the same. but my actual voltage that comes from the battery ends up getting divided among those 3 light bulbs. Okay, so you guys are notice today, as you add more and more light bulbs, it's going to get a little bit dimmer and dimmer and dimmer. It's going to be hard to kind of see it, so we'll have to turn off all the lights for today. So more light bulbs, more resistance, less current, dimmer. Okay, so this is a schematic diagram. On yours, if you're following along, you can actually see they have an actual battery hooked up to actual light bulbs. And your job would be to actually diagram this in terms of a schematic. So to draw it as a schematic, 1 battery, 1, 2 light bulbs. Remember, since they're in series, there's only going to be 1 path for those electrons to flow. So what happens if this one burns out? The rest of them are going to be burnt out, okay? Today, when you are looking at 3 light bulbs, not every single light bulb has the exact same resistance. Some of them are newer light bulbs, some are older light bulbs. Okay, some are the same brand, some are different brands. So this one might look like it's on, that one might look like it's on, but this one might look like it's off. If those other 2 are on, do you really think that second one's off? No, definitely not, because if it was off, then all of them would be off, right? So today, once you get up to 3 light bulbs, the resistance is so much, you're actually only going to probably see the filament in the bulb glow orange. You won't actually see a bright visible light. Now, to double check it, you could add more batteries and double check, make sure that they all are actually on and actually working. Okay? All right, so parallel then. Our definition, remember, is that all of our components are going to be connected individually to the, battery or in the circuit, okay? So all going to be connected individually. So if they're all connected individually, that means they're all getting the same what?
Things like the
Voltage. I'm going to get the same voltage. Now if you look, how many light bulbs do I have here?
2.
I have 1 path here, and then I have another path there. So let's say this one burns out. Will the other one still turn on? Yeah. Since they're each connected individually to that battery, let's say that's my 9-volt battery, each of them gets 9 volts. So they're each connected individually. You'll check it out. You'll try it out, and you'll see. Double check. You'll see it.
You keep drawing your arrows from positive to the
I know. It's okay.
Okay.
Yeah. And that's why we talked about it. That's why we talked about it. You'll see it both ways. All right, so question though. If the current leaving the battery is 10 amps, what do you think is going to happen when it gets to this juncture and I need some current to go there and some current to go there? It's going to split, right? And it doesn't necessarily split evenly because the resistance in those 2 light bulbs might be a little bit different. So let's say maybe I get, what was our total current? 10 amps. Let's say I get 7 amps to come here. How many would go in the other one? 3 amps. It totally has to add back up to 10 amps though. So I'm going to have 3 amps all the way around on my green little loop. So coming back in, I still have 3 amps. On the blue loop, I have the 7 amps. But then once they join again, what's my total current coming back? 10 amps. So that's one of the things that you guys will kind of do next when you take that next step, whether that's in engineering or in physics. You'll actually look at, well, how much current is going through each of my loops, okay? So as you're looking, again, they're all connected individually. So I can add more light bulbs. I can let one of them burn out. It's fine. There's going to be multiple paths that the electrons can travel. So my current's going to get divided, but since they're hooked individually to the battery, my voltage is going to be the same. Okay? All right, so help me out. Take a look at some of these pictures.
Okay.
Parallel or series? Series. Parallel or series? Parallel. What are these called again? Resistors. Parallel or series? Series. This one? Parallel. This one? Series. This one? Okay, now look at this one. These two are what? These two, though, are, yes. So there's an actual way that we can solve for the equivalent resistance in a circuit, okay? And so that's kind of where we'll be going at the end of tomorrow into Friday, probably Friday, depending upon how fast you guys move through building all of our circuits, okay? So our goal for today is to be able to draw diagrams like this. Please do not draw this today. Don't draw this guy. I don't want to actually see the components. I want to see it with our symbols for our batteries and our light bulbs. Sound good?
All
All right.